Hey, welcome back to some practice involving one of the most commonly seen parent graphs and parent functions in all of the algebra courses, the graph of y equals something squared, or y equals x squared. The skills required to be able to understand this exploration are to remember what are the three key features of these type of graphs. If you don't remember, go back to the previous video. See if you can remember them before I write them down. But remember, the idea for that was knowing these three things will allow us to quickly sketch the parent function and some type of transformation. The first transformation we saw before. So I'm going to write them down. Hopefully you remember. One of the most important things, and the previous part it was not complete, so we'll make these notes complete today. The most important part for all of these type of graphs is that they have a lowest or a highest point. And that is the most important part. Particular point on these graphs, because we'll write more notes about it. I'll call it point for now. You can think of y value, that's fine. And I will write its actual name down here, okay? So it's either a lowest or highest point. And the reason why that's the most important one, in my opinion, is because these type of graphs have symmetry. And I always ask, where does the line of symmetry pass through? It's always through the lowest or highest point. And you know what? I'm going to do that now. I was going to wait a little bit longer till we finish this. But at some point, I'm going to get tired of calling it lowest or highest point. There's a special name for that in math. If you do know what that's called, I'll put it in parentheses here. But the concept is understanding a lowest or highest point. If you feel comfortable with that idea, then we can start to call it the vertex. And if you never heard that term before, then I will use it. Just know that when I do use it, I'm referring to a lowest or a highest point. And the reason why I wanted to do that is so that here I can write symmetry through vertex. If you want to be more specific, I'm going to say line of symmetry. Always passes through the vertex. All right. And the last thing on number 3 that we wrote is that these type of graphs have curvature. Curvature, we discussed 2 types. It could either curve up or down. And those 2 examples are on the left side. Hopefully you remember which one is which. Curvature, it could be up, curving up, meaning pointing upwards, or down, pointing downwards. Let's use better arrows, or a better arrow down here. Yeah, that's a little bit better. All right, so I will be sketching these. Remember, these are the 3 things we summarized in the previous video, and we will use that information to quickly sketch stuff like this. Y equals something squared, we know it has a lowest point. And what's the lowest y value something squared can be? We've done it many times. It is 0. What x value did we square to get that 0? Don't forget, it was x equals 0. And I will call that the line of symmetry and draw it right there. And label it as x equals 0. Remember, the equation for the y-axis is x equals 0, since all x values anywhere on this line are 0. And then last thing we know is that it curves, and it's got symmetry through that most important point. That's why I call it the most important point on the graph. Once you know that, then you can make a quick sketch. And we're going to use that similar thinking for this next one. Look, how did this original parent function get transformed to this one? Now there's a negative. So let's analyze what's going to happen to everything that was positive before. And if now we're multiplying by -1, every positive y value that should have been up here, it will now reflect down here. Okay, think about it like that. What happens when you multiply 0 by a negative? Then you still get 0. So notice how the vertex didn't change, but it became from a lowest point to a highest point. In a calculus class, we would say this is it became from a minimum to a maximum. All right. And just to make it a good habit, I will, even though I already drew it, I'm still going to draw the line of symmetry. Always keep it in mind. It's a good habit. Knowing these 3 things will help you transform. This is our first transformation. That was pretty simple, but more advanced stuff in the next few numbers. And just I want to emphasize which one of these 2 was curving up. Here we go. Look at the arrows. This one's pointing upwards, therefore curving up. Look at the arrows. They're pointing down, so therefore curving down. All right. Keep that in mind. And I will draw a line right here to separate these 2, number 1 from number 2. And we will start sketching the graphs. And I do want you to think, when I say that, let's do it as quickly as we can. And let's do it by transforming the parent function. All right. So the key question to keep in mind is, how did the parent graph transform to these following ones? Matter of fact, as of right now, we see 4 parent functions. Even though they're not written as y equals x squared the way I wrote it up here, I still want you to think this is still a y equals something square equation. This one says y equals negative something squared. So how do we read all 4 of these? The same way, y equals something squared. Some of them will get more advanced than others. The first one's going to be y equals x squared. The something is just x. So again, that's something we already did. That's the same as this one. We know that it has a lowest y value when x is 0, because what's the only thing that can make x equal to 0 is x equals 0. No other choice. And vertex is 0, 0, and it's curving upwards. Why? Because it is positive something squared. And even though it's not the most perfect graph, that's a very accurate sketch. All right, but remember that in algebra, things are not always this easy. They get a little more complex, not in difficulty, but how they look like. Even though we think y equals something squared, now the something won't be x by itself, it would be x plus 1. The next one is still a y equals something squared type of graph, but the something is a little more advanced inside. It's x minus 3. And the last one will be y equals something squared, but with a something of an expression of x plus 4. So let's see how those expressions affect the parent graph. So the first thing that I see is how do they affect it right now? I see pluses and minus, but let's think a little bit more. Y equals something squared. We're going to think of the plus 1 later, right? Y or the x plus 1 later. We think y equals something squared first. What do we know is the lowest y value that can be? It is 0, just like the previous one. But the question before is whenever x is equal to 0, that's the only number you can square to get a 0. But this doesn't say x anymore as this inside expression. Now it's x plus 1. But the question will remain the same. How does x plus 1 become a 0? The goal is to make this a 0. How do we make it a 0? When x is, think of one number as I'm writing it down. I'll only write it down one time. How do we make that into a 0? Give you more thinking time since I need to erase my letter Z and rewrite it. And time to check. How do we make it a, that was not, there we go. How do we make it a 0 when x is negative 1? So be very careful with that because it says x plus 1. Negative 1 plus 1 indeed is a 0. Oh, not negative 10. So there it is, negative 1, x equals negative 1. The y value is still 0. When x is negative 1, the y value is still 0. We found the most important point on these type of graphs because we know the line of symmetry passes through there. And we draw a curvature about that. Remember, it's y equals positive something squared, therefore curving up. The next two are also y equals positive something squared, so hopefully you're already thinking that. And again, y equals something squared, the lowest y value, when this inside part is 0. What value of x makes the something inside equal to 0? When x is 3. So I'm going to draw a line of symmetry because we know that the vertex, whether it's a highest or a lowest point, will pass through that line. And then we know that when x is 3, we get 3 minus 3 squared. 3 minus 3 is 0, and then 0 squared is 0. So there we go. That gives us the 0 as the lowest point. 3 comma 0 is our lowest point because it's positive something squared, curving upwards. And hopefully you're visualizing some symmetry. Try your best to do that. I know they're pretty difficult at first, but look how quickly we made 2 of them. And keep this question in mind. We will come back to it. Y equals something squared. Again, I know the lowest y value something squared can be 0, but only when the something inside is equal to 0. What value of x will make this x plus 4 equal to 0? When x is negative 4. Negative 4 plus 4 is 0. So when x is negative 4, we have our 0, and it's positive something squared. Therefore, this curves upwards. And symmetry about this line. All right. Try not to get these two confused. This is its own graph right here in the middle, and this last one on the right is its own graph. Okay? There it is. And I do want you to think. I'll write the answer later, but test your theory right now. How did this parent function? I'll label it right here. This is the parent function, or the parent. Those names are interchangeable in this course. Parent graph. They're down here. I'm having trouble spelling today. I think it's because I'm trying to rush it, but it's all right. How did this parent graph become this one on the left? Try to visualize some movement. How did this one become this one? How did this parent graph become this one in the middle? Try to visualize that movement, and same thing. How did this parent graph become this last one? And try to visualize some movement. How did it move to become that one? And I'll write the answer later. Let's keep testing some, however, with a little bit more going on. Notice how all of these are some form of y equals negative something squared. So they will resemble this second graph rather than the curving. I wanted to mix that up. Graphs that were curving upwards and graphs that were curving downwards in the same type of example. So there's a lot going on here. All right. The first one will, of course, be y equals negative something squared. We've seen that one many times. What's the only way this x can be 0? When x is 0. So we've seen that many times. And that lowest or highest y value is going to be 0, 0. Now the question is, look at the symbol in front. Is it positive or negative something squared? It is negative something squared. So therefore, it's going to curve downwards. I'm sorry, but my line of symmetry is supposed to be right there on that line, x equals 0. So there it is. That's the main difference. You see that? We have already seen that many times. So all of these graphs just have that type of curvature. If you are not paying attention to it, it's good to check in your work. But look, the something inside is not going to be x always. Otherwise, we would be done with this video. It would be something like x plus 3. And test what you probably learned above in the first 3 examples to see if it still applies to these. The next something is x minus 6, and then y equals negative something squared, where the last something is x minus 5. All right, so it gets a little more advanced, and let's see what happens. Again, remember that the highest or lowest y value is 0, but only when the something inside was equal to 0. This case is x plus 3. How does x plus 3 become 0? Only when x is negative 3. Negative 3 plus 3 is 0. Then when you square it, you get a 0 square. I mean, 0 squared is just 0, so it's the same. But what type of curvature do we have? Is this curving upwards or downwards? So I labeled the most important point of the graph, the vertex. But notice the negative something square, which I had mentioned previously not that long ago, and there it is. And start to think, how did this one become this graph right here? But most importantly, how did this is the actual parent graph. How did this original parent graph become this one? All right. And again, we will keep thinking the same. Y equals negative something squared. The highest y value is 0. What value of x gave us that? When the something inside is equal to 0. And that is when x equals 6. When x equals 6, we will have our vertex, meaning a highest or a lowest point, if you're not thinking about that yet. But it's still a 6, 0. 6, 0. And notice that it's negative something squared. Therefore, we know it's curving downwards. And that would be sufficient, all right, for a quick sketch. Look how quickly we're making these. And same thing here. Y equals negative something squared. The highest y value in the previous 3 examples is 0, but only when x is 5. When x is 5, the something inside becomes a 0, which does give that highest point. X equals 5 gives us 5, 0 as a vertex or highest point in this case. And because it's negative something squared, there it is. All right. So let's write down, summarize a little bit of something. However, let's be very careful. How did this original graph x squared become this transform graph? The plus 1, did it make it move to the right or to the left? Matter of fact, are all of these moving side to side? Are they moving up or down? Meaning vertically versus horizontally. If you're not confused, just think side or side to whether it's left, right, or if you're thinking up and down. Did any of these move up or down? The answer is no. Did they move left or right? Yes. And let's find out how they did that. Does the plus 1 means that the parabola moved 1 unit to the right? And look at it. No, it moved 1 unit to the left. All right. Does the negative 3 means that it's 3 units to the left? As we would think if intuitively, it doesn't mean that. It moved 3 units to the right. What does the plus 4 imply then? It means 4 units to the left. And if you're confused about that, remember, we were trying to make it equal to 0. Only when the something inside is 0, our goal is to make the something inside. And that's why we always do the opposite. If we see plus 4, we do negative. We moved 4 units to the left. If we see minus 3, we move to 3 units to the right to make that 0. Remember, we're always trying to find that y value of 0. So I'm going to say the parent graph, if you're okay with left to right, I'm just going to say horizontally right now. Parent graph moves I can say left to right here. That's fine, just to make some more connections, easier transition. Left or right. Now write the actual term right here. If you understand that idea, let's test it right here. Did the +3 move it to the right or to the left? It moved it 3 units to the left. Look at that. The -6, how did it transform the parent graph? It moved it 6 units to the right. And the -5, 5 units to the right. This type of movement is called horizontal movement. Horizontal, that's the textbooks and mathematicians' way of saying horizontal. As a matter of fact, they don't say movement, they say translation, but I'll use something that's a little more easier on our daily vocabulary. Horizontal shift, and all that means is something moving left or right. Think horizontal like the horizon, or think horizontal like flat ground. How do you move on flat ground? Side to side, okay? So I do want you to think that. And there was another type of transformation here. That was the negative in front of the something square. That reflects the graph downwards, all right, which we set up here. It makes it curve down. But if you just say horizontal shift and curving down, that's perfect, all right? So for example, I'll do one, just not to spend too much time. How did this equation right here get transformed from the original? We would have to say something like the parent function moved 6 units to the right, and then it reflected downwards, all right? Or more sophisticated way, it could be it reflected vertically. But that's not the main goal of this. Vocabulary is not the main goal of this video. Is just for you to understand the concept first, all right? So once you understand that, hopefully, what type of transformation in the equation causes horizontal, meaning left or right movement, we're going to be pretty advanced and be able to do things quicker in the future, all right? Because there's other type of movement. Let's explore it. What do you think is another type of movement besides horizontal? Let's check on number 3. I do want to point out that if you're a little confused, and this video might be one of the longest at this point, and you may want to break it up in 2 parts, you're more than welcome to. If you feel great, then let's keep moving. You can do it all in one sitting. Y equals something squared. What do we know about that? That's the parent function. It has a vertex when x equals 0, because only 0 squared gives us that lowest point. 0, 0 is our vertex. And I lost grip on my pen, so even though I'm trying to do this quickly, I'm still trying to do it as accurately and carefully as possible. There it is. I'm very happy with that one. That was very quick. All right, next one. Hopefully you notice a resemblance. This one, I can read it as y equals something squared. And the next one is y equals something squared plus 1. Let's pretend that the plus 1 is not there. It is there, but we'll come back to it. If the plus 1 is not there, then how would I read this? Y equals something squared. Isn't it the same as this one? So we know what part of this looks like. Matter of fact, we know what the lowest y value, and I'll use some color. What's the lowest y value that this part can be? I'll highlight in green. What's the lowest y value this part can be in green? And we've seen it many times, it's 0. But now we have a different question, all right? Now underline it. What's the lowest y value this whole expression underline can be? So if the lowest this part can be is 0, now our new lowest y value is 0 plus 1. So what's going to be our newest y value? It is going to be a 1. But remember, what value of x makes that 0? So I probably would like to start with that, all right? So still going to be the same line of symmetry. But remember that this part, the lowest y value is 0. Now we're adding 1 to that. What's our new lowest y value? It is going to be a 1. When x is 0, we have our lowest point, but now our lowest point is a 1. And hopefully you can tell where that's coming from. And it's still a type of graph that has curving upwards. Oh, and I did miss this because I think I was rushing it. So I'm going to go back and do it now. It won't take that long. And I do want to put in notes. These type of graphs do have a special name. And because I feel like we're comfortable with that at this point, the name of this graphs in mathematical terms is these are known as parabolas or quadratics. Quadratics is the even more formal way of naming them. But these are parabolas. If you ever heard that term, that's what they are. If you haven't, I will start to use that now. This is a parabola. This is a parabola. The difference, this one curves downwards. This one curves up. All right, so there it is. These are all parabolas. And these are all parabolas, all right? So the next parabola, I want you to think, all right, this resembles y equals something squared. I already know the lowest y value that can be, and that's when x equals 0. So that's the way I always like to start these. This one has a lowest or highest point, or meaning a vertex when x equals 0. So I know that the y equals x squared part, the lowest that can be is 0, but now we're subtracting 3 from that. What's our new overall y value now? And it will be 0 minus 3. That means that when x is 0, the lowest y value now is negative 3. And still has curvature, and it still has symmetry. And again, doesn't have to be the worst looking parabola, but hopefully accurate enough. And I'll accept that one better than the last one. All right. And same thing here. Now notice I'm starting to remove less parentheses because that implies, and I do want you to pay attention, what is being squared in this quantity? Only the x. What is being squared in this equation? Only the x. And what's same here? What's being squared? Is the plus 8 being squared? No, only the x. So that does tell you that if you wanted to yourself visualize them, then put them there for yourself or visualize them. That way you know, oh, what makes the inside equal to 0? That's when x equals 0. That's how we always figure out where the x value for the vertex will be located. And when when 0 squared gives us our lowest point, then our new lowest y value is 0 plus 8. What's our new lowest y value for this graph or for this parabola? It happens when x is 0, but that new lowest y value is 8. And notice how now we have, oh, I always have trouble with that first attempt. But you take your time with these yourself. All right, and if I need to, there we go. That looks a lot better. But there it is. And I want us to start thinking just like before. How did this parent graph become these three? And I do want you to visualize movement. Like before, did it move to the left? Did it move to the right? Did any of these move to the left from 0, 0 to a left or point on the right side of the vertex? No, it doesn't seem that way. Did they move up or down? So I do want you to think what kind of movement. All right. So we will write that down later, I guess. We will, yeah, let's just keep exploring some with negatives, but it's going to be the same type of movement. And I guess I have another one here. As you can see, something squared, the lowest y value this can be is 0 when x is 0. So I will always start with that x value. It's just much easier to help you find that lowest or highest point. When this part is 0, then we get 0 minus 5, which now we know the vertex is at 0, negative 5. And it's positive something squared, therefore it curves up. Symmetry still passes through that lowest point or through that vertex. And there it is. That's very quick to do. We should recognize this one already. When x is 0, we get a vertex, and it's negative something squared. This one we've done a bunch of times. 0, 0 is the vertex. And look, a nice way of connecting this, you can think of this one as negative x squared plus 0. There it is. There's a 0. And you can think of the first one as something square and plus 0 on the outside, right? They're the same. So it didn't move up or down at all. That's what it's saying. This one moved up one unit. You can see this. Now this plus 1 does imply up 1 unit. How did this one move from the original parent graph? This negative 3 implies down 3 units. And what does this plus 8 imply from the original parent graph? How did this parent graph become the third one? It moved up 8 units. So that's what we're seeing. We're starting to see, and I will say up and down movement, but I'm trying to be a little bit more connected to horizontal. We will say vertical movement. And if you want to be more specific, vertical shift or vertical translation. But as long as you understand that concept, which is the point of this video or this lesson. And then there's 2 ways that you can see that. Look, notice how this one says negative something squared plus 3. It does mean only the x part is being squared. If you need to visualize it, I always advise then write it like that or visualize it like that for yourself. And then this still does mean up 3. This will actually mean up 3 the way that this meant down or up 0, and the way that this meant down 5. And this still means reflect downwards, meaning curving down. So we know that the only thing that makes x equal to 0 is x equals 0. So line of symmetry is at x equals 0. It moved up 3 units, and we have 0, 3. And because it's negative something squared, we know that this is going to curve downwards. But even still, look how quickly we made that sketch. What I want to point out is that these two are the same equation. They're just written differently. Notice how it's positive 3 and it's negative something squared. So what I want to point out is that it's the same graph, but you will be seeing me write it in this format more often than not, all right? So these two are the same. I won't be graphing it again. Just know that. And the reason for that is in the future, our graphs, at least for this course and a lot of textbooks, they're going to be more of the form, especially when it's minus something squared, it's going to look more something like 25 minus something squared. Instead of me writing negative x squared plus 25, because that's going to look more advanced later, something more like 25 minus something squared, where the something inside is an expression like x minus 6 or x plus 8. You guys get the idea. We make these more advanced as we go along. So that's it. If you understand those two, my goal would be to try to put those two ideas together. Everything we've done up to this point with graphs, transforming them, put it all together. And again, I recommend if you need this time to take a break and then return to this video the next time or tomorrow, whenever it is that you're going to practice, go ahead and do that. If you feel okay and you understood everything up to this point, then let's move on. And if not, don't forget to ask questions. Give me some feedback. Maybe I could do a follow-up video to this. But look, I want to do 6 examples that are of combined. It's not one, it's not 3 of each, and it's just combined mixed practice now. First of all, to see if you can recognize the format and the type of transformation, whether it's horizontal or vertical, and also to see if you're paying attention to the type of curvature. My goal is to, for all of these, I'm going to advise you, try to identify the vertex first, whether it's the highest or the lowest point. And hopefully you're starting to think about that. And let's check to see, because the goal is to do these quick, all right? All right, so hopefully you identify this as y equals something squared, y equals something squared. If you even want to think or write a plus 0, that would be helpful, but it's not needed. Then I know the lowest y value 0 when this part is equal to 0. That is when x equals 4. When x equals 4, we have our lowest y value, which I already wrote as 0. Now my next question is this a curving up or curving down? Is it positive or negative something squared? It's positive something squared because there's no symbol written. If there's no symbol, you can assume that it is a positive. And I'm thinking about x, but it's 4 comma 0. I was thinking too much about what I was saying here. All right, let's move on. Look, positive something squared says that there's no negative implied. Then that means that where's the line of symmetry? Notice how this implies up 6 units. So I'm starting to think whenever this something inside is 0, that's when we have our line of symmetry. And that only happens when x is 0. I always like to start by finding the x coordinate first of the vertex. Oh, I didn't even finish the last one. That looks like a line. There's no curvature to that. See, I got too many things on my brain right now as to what I'm going to do next. And sometimes when I rush it, it happens. It's okay. All right. And I know that the highest y value here, it's a 6. So when x is 0, we get a 6. And that's just vertical movement upwards, 6 units. And the previous one had horizontal movement, right, 4 units from the parent function. All right. And there's a strong connection between these two problems here and this next one right here. As a matter of fact, it'll be easier to see if I remove this again. But look, there's a strong connection between these two and the third one. And that was done on purpose. Let's see if we can identify that. All right, so I noticed this something squared plus or minus a number. To find the x coordinate, the something inside's got to be equal to 0. What makes the something inside x minus 4 equals 0? When x is 4. So that's where I always like to start. Find the x coordinate first. It'll be the easier thing for us. And what is the y value when this is 0? It becomes 0 plus 6. That lowest or highest point, now it's 4 comma 6. So I'm going to write it as 4 comma 6. It is a coordinate point, and then ask myself, is this positive or negative something square? It is positive something square. Therefore, we have this type of parabola curving up with some symmetry about that line. Remember that the line of symmetry is not part of the graph, but it's a really good guide to making these graphs more accurate. Okay, next one. Oh, before I move on, did you catch the similarities between these? From the parent function, this one moved 4 units to the right. How many did this one move? 4 units to the right. Look at that. X equals 4 and x equals 4. All right. How did the second one get transformed from the parent function? It moved up 6 units. And how about this one? It moved up 6 units. So this graph right here has these two transformations combined. Moving the parent graph 4 units to the right and 6 up is this graph. This one only moves 6 up, and this one only moved 4 to the right. This one combined the movements. The next few are just random ones. Let's see if we can do them correctly. All right. The other thing I will tell you, I guess, no, I'll tell you later. Let's keep going. All right, let's find the x value for the line of symmetry. What value of x gives us a 0? What makes the something inside equal 0? When we have a -3. Line of symmetry is at -3. That means the vertex is at -3. What's the vertex in that case? -4. When x is -3, we get 0 minus 4 as our new lowest y value. And a vertex of -3, comma, -4. And now we have to ask ourselves, was this a positive something squared or a negative something squared? Because there's no symbol written, it's implied positive. And some of you that are more advanced, you may see, oh, I'm not even checking it myself. I might have had the incorrect x-intercepts. That's not the point of this video. The point is finding this one and being able to draw a curving up or downwards, all right? Not that it's not crucial. It's just not the priority for this lesson, but it will be a priority soon, all right? So stay tuned if you're curious as to how to do that now, or if you already know how to do that. I'm sorry if I made a mistake. It's not on purpose. All right, so but finding x and y intercepts will be a priority later, just not right now. All right, next. And see if you're doing them, finding the correct vertex yourself. That's all I'm really checking. I think of this one as 9 minus something squared, 9 minus something squared. So it means that only the x is being squared. That means the line of symmetry only when x is 0. When x is 0, then we get a new y value of 9 minus 0, which is 9. So therefore 0, comma 9. And what's the negative belong to? The positive or the something square? The negative belongs to the something square. Therefore, this is curving down. And again, those of you that are curious as to where did it cross the x-axis, that's not the point for this video. So just stay tuned if you really want to know how to do that soon. All right. And hopefully you see that connection. This one can be thought of as 9 minus something squared. Guess what? This is also 9 minus something squared. This is the same type of problem, but with a little bit more going on. Another transformation going on, which is where I like to start. What value of x gives us our vertex or line of symmetry? That's when the something inside is equal to 0. That will be when x is -5. When x is -5, we will have our line of symmetry and our vertex. What is the y coordinate of that vertex? Is 9. -5. And hopefully you're starting to see how those work. -5, comma 9. And then again, the negative belongs to the something square. Therefore, it is concave. Concave means curvature. It's a more advanced way of saying it. I'm a calculus teacher, so that one just slipped. But it's just curving down. And again, I'm not too worried about whether my x, where it crosses the x-axis is correct right now. It could be a much wider parabola. It could be something that looks like that. For this lesson, this is perfectly fine. But I do want you to compare these two. They both have the same y value. What's their only difference then? They are both curving down. They're both the only difference is their x coordinate for the vertex. It changed by 5 units, and hopefully you can see that. And because this was +5, this is a -5. We're trying to make that 0. That's the key. Good. Hopefully those connections are being made. If not, give it some time, ask some questions, and try to create your own practice problems or ask for some advice. All right, here we go. I always like to start with the x coordinate. Where's our line of symmetry? When this part is equal to 0. That is when x is -6. When x is -6, we have a y value of 2. Hopefully you're seeing that a little bit quicker every time. Now I can label -6, comma 2. And it's positive something square. Therefore, this is curving upwards. And look how quickly we were able to make that. That's very quick. All right. Next one is 7 minus something squared. The something inside has to be a 0, and that is when x is 3. When x is 3, we have our vertex and line of symmetry. And what is that y coordinate? It is 7 because we will have 7 minus 0. That doesn't change. So 7 minus 0 gives us a y coordinate, x coordinate of 3 and y coordinate of 7. All right, hopefully you're starting to see that and are getting quicker at it. And last thing, identify negative something square, therefore it curves downwards. And again, like I said, I'm probably going to do this wrong on purpose. It might be right. I don't know. I'm not checking. But I don't know if the wideness of my parabola is accurate. That would be a priority for another lesson. But as long as you can think, I know the vertex is 3, 7. I know the parabola curves down. Or for this one, if you thought, I know the vertex is -6, 2, and the parabola curves up, oh, you're in really good shape. All right, that is it. That's combining all the ideas. In terms of graphing it, the last one, if you don't want to stick around, you don't need to graph them, but it'll be very quick. One last type of exercise would be just without graphing, you could be asked, what is the vertex? And hopefully you can find, it's just 4 of them. If you want to identify them really quick and then leave, that's perfect. If you want to stay and check them with me, you're more than welcome to. But I'm going to check them now either way. So because I wanted to write this a little bit lower, I'll give you a little more thinking time. If you're still thinking about them, that's fine. And what I'm writing is X and Y coordinates. So for example, this is not the correct one, but if I ask what's the vertex, and it should be in the format of like 4 comma -11, if that was correct. But let's check it now. Remember, always start with X and then Y, X comma Y. So what would be the vertex for this first one? The vertex would be X equals 3 and Y equals 10. But now I'm just gonna say 3 comma 10, right? Just know that X implied X comma Y. What's the vertex for this one? It should be when X is -4. So -4 comma 7. What's the vertex for this one? It will be, oh, let's give you some thinking time if you haven't looked at it. I don't know if I blocked it. There we go. What's the vertex for this one? Is -8, -2. And what's the vertex for this one? I'll give you a little more time for that one. It is 5 comma 16, all right? Remember that it's whenever the something inside is 0, you have to take the opposite of those, and the Y value is usually the same. All right, that was a lot of practice and a lot going on here. Like I said, if you need time to break this up, if you watch the whole thing and you're still confused and you need to rewatch certain parts, it is not a bad idea. We had 3 type of transformations, and at some point we could even combine those. So just remember that it was a lot going on. If you don't feel confused at all and you feel really good about this, you're ahead of the game. I congratulate you. But either way, I hope that you are honest with yourself and know when to move on and when to stick with a concept and revisit it. It's not bad to do that. So there are no more things that I have in mind to share at this point. We have come to the conclusion of this practice. I really look forward to expanding this more on this idea. We're just scratching the surface, and stay tuned. There's a lot more going on that's going to be going on here, and I'm really excited to show you. All right. Have a good rest of your day.